Today we are going to start off with Cambridge O-level physics paper 4, that is alternate to practical, and this is May-June 2022, and the paper code is 5054/41. Let's begin our question number 1. A student investigates how the temperature of volume of a water changes as hotter water is added to it. 160 centimeter cube of water at 20 degrees Celsius is poured into the glass measuring cylinder. Figure 1.1 shows the measuring cylinder, and the measuring cylinder contains 160 centimeter cube of water, and you need to draw the level of water and showing the meniscus. So in this question you need to understand this thing. Then whenever the water there is a colorless liquid, so you have to draw the lower meniscus like this, and whenever you have a colored liquid, so this is for colorless liquid, and if you have a colored liquid, so then you are going to draw your meniscus like this. So this is going to be your meniscus. This is going to be the right, avoiding the parallax error. So in this question what we have to do is you have to draw the meniscus at 160 centimeter cube, and we don't know this thing. So what we are going to do is, first of all, we have to find out the volume. So it's going to be 175 minus 150 is going to be 25 centimeter cube. So now count the number of lines between 150 and 175, that is basically the divisions or the marking. So what we are going to do is 10 divisions is equals to 25 centimeter cube. So 160 centimeter cube equals to x. So now you cross multiply, so it's going to be 64. So basically you have to draw the marking on 64. So this is going to be, these are the 4 lines. Okay, so I'm going to be drawing this level somewhat like this. Okay, so this is going to be the answer for the first part. Moving to the next question, and it states that the student pours 100 centimeter cube of water from the measuring cylinder into a large beaker. He then uses a kettle to provide a constant supply of hot water. Adds 50 centimeter cube of hot water at 70 degrees Celsius to the beaker. Stirs the mixture. Records the new temperature of the water in the beaker. Continues to add 50 centimeter cube of water at a time, recording the new temperature for each addition until the total of 300 centimeter cube of hot water has been added. The student ensures that temperature of the water added in each time is 70 degrees Celsius. Suggest how this is going to be done. So first of all, what you have to do is, you are going to pour the water 50 centimeter cube into measuring cylinder, and so then you have to use a thermometer to check the temperature of water, and then wait till it reaches 70 degrees Celsius and then pour it into the larger beaker. This is how you have to do it. Okay, moving to the next question. The student repeats the experiment and obtains 3 sets of results as shown in figure table 1.1. Okay, so what is this? This is basically going to be, if you see this data, so it's going to be the average of this value. So 20 plus 20 plus 20 divided by 3, you will end up with this answer. So over here we are going to add these values. So it's going to be 47 plus 49 plus 46 divided by 3. So let me use the calculator. So the answer is 47.33. So these are two significant numbers, so I am going to write 47. Calculate the average. Okay, this is written over there as well. When the total volume of the hot water is added this, record the table and answer, and this is the required thing that you should be answering your basically you should be answering in significant figures. Okay. On the figure 1.2, plot a graph theta average per degree Celsius on the y-axis against volume per centimeter cube on the x-axis. Start both axes on the region. Draw a smooth curved line of the best fit. So now this is your graph. So in this case, first of all, we are going to decide again. Remember this thing, that the important thing is this, that you should be writing down your axis. This is going to be y-axis, and what data you or your quantity you are taking on this. So I will be taking temperature on this, which is going to be in degrees Celsius, and on the x-axis I will be taking the volume in centimeter cube. This is basically also given in the question as well. So first of all, this is going to be, by looking at the data, what I need to do is 10, 20, 30, 40 degrees Celsius, 50. This is going to be 60. Okay. And then if you talk about with the volume, so how would I take this value? Let's say I'll take this as 50, 100. This is going to be 150 and 150, and then it's going to be 200, 250, and this is going to be 300. Okay, centimeter cube. So when you draw this graph, so it's going to be like so here's the graph for the plotted values, which is given in the previous question. So this is going to be a regular graph. Mine one is a little bit not regular and not uniform. So just to give you an idea how it's going to be solved or how it's going to be, so you have to draw it with a free hand. Okay, moving to the next question. What your graph shows theta average is not directly proportional to V. Describe how your graph shows this and suggest why theta average is not directly proportional to V. So now at this point, you need to identify why this graph is not directly proportional. So you guys can write any of these statements. First of all, it's this is not directly proportional, so it's not starting with the origin. First of all, not starting with, or you can say from origin. That's why it's not directly proportional. It's not a straight line, and the gradient is also not constant. So these are the reasons that why this is not directly proportional. The student repeats the experiment with layer of insulation around the beaker, and your graph in figure 1.2 sketches a line to show the results with a layer of insulation around the beaker. Label this line with the letter A. So obviously when you have insulated your beaker, so the amount of temperature is going to be decreased less as compared to the one with the without insulation. So here's the graph for this. That is the answer for question C. Moving to the next question. A student investigates the resistance of two resistors. Figure 2.1 shows the apparatus used to find the current I in resistor X and the potential difference V across it. Draw a circuit diagram for the arrangement of the shown in this figure 2.1. So this is how you are going to solve this. It's going to be the first this battery or a cell, then there is going to be a switch, then it's going to be your resistor X, and then it's going to be your ammeter, and then it's going to be your battery, and then you are going to add your voltmeter across the battery. So this is how it's going to be. Okay, Moving to the next question, and it says that the student records the current I and the potential difference V across resistor X when the switch is closed. He calculates the resistance X, Rx of the resistor X. He replaces X with the resistor Y and repeats the experiment. The value for both resistors are shown in table 2.1. The values are given, calculate the resistance Ry and complete the table there. So over here the formula is given. So now the voltage is what? 1 volt, and the amount of current is what? For this is 0.0.7. So this is going to be what? If you divide this one with this, so you'll end up with 14.28. So it's going to be 14 ohms, so I'll write 14 over here. Okay, so you have to write your answer with the whole number thing. Okay, the student combines the resistor X and Y in the parallel arrangement. He uses this combination in the circuit figure 2.1 and places the reading this. Okay, basically what you have to do is you have to find out the reading on this scale. So now you see this thing, this says like again 1 2 3 4 5. So okay, it's 10. So how would you do this? 0.2, this is ammeters, amps on 10 divisions. So now how many divisions are there? There are 8. So 8 divisions equals to x. So you cross multiply 0.2 divided by 10. So it's going to be, if you do the calculation, so it's going to be 0.16. So this is your final answer. Okay, moving to the next question, and it says that the potential difference stays 1 volt. Okay, they're using the value I in B2 and equation in B1. Calculate the resistance RC of the parallel combination. So again, we are going to use the same formula. This is going to be R equals to voltage divided by current. So this is 1, and the current is 0.16, and this is going to be 6.25 ohms. So I'll write 6.25 ohms over here. Okay, theory suggests that the resistance RC of the two resistors X and Y arranged in parallel is equal to 2. State giving a reason whether your value for RC in B3 agrees with this suggestions or not. Okay, so first of all, I'll do some calculations to check 10 14 over 10 plus 14, which is going to be 5.83 ohms, and the difference is going to be 6.25 minus 5.83. So 6.25 is this one, the one which is we have already calculated for this. So this is going to be 0.416. So now we will find out the percentage difference, and this is going to be 0.416 divided by 6.25 into 100. So it's going to be 6.4 percentage. Yes, the both are with the within the experimental accuracy. Yes, both are within the experimental accuracy. Moving to the next question, and it states that a student directs two parallel rays of light, ray 1 and ray 2, towards the sides of the transparent plastic block as shown in the figure 3.1. The block rests on a sheet of paper. The student marks 2 points R and S on the path of ray 1 after it has passed through this. On the figure 3.1, draw a line joining SR and continue the line to meet the block. So you have to draw a straight line with the help of a scale. I'm using without that. So you guys are going to use the scale. On the figure 3.1, draw the line to complete the path of the ray through the block. So if you do this thing, I'll suggest it's going to be like this. Okay, the student marked 2 points W and X and the path of the ray to after it has passed through the block. So now in this scenario again you are going to do this because I have studied this question, so that's why I'm doing this. Otherwise you guys have to just make a line from wx with the help of a scale and complete the race. Extend the line SR and XW back until they meet and label this point F. So this is what I did, and this is what I have already done. Measure the perpendicular distance from F to the center of the block. So basically what they are asking is this distance. Let me change the color. This red line, and this is going to be the optical center, and this whole distance is going to be your focal length. So over here the question states that you have to measure it. So by using the with the help of a scale, so it's going to be like 2.3 centimeter. So you guys can do it easily. A student determines the diameter of a thin wire. The apparatus available is 2 meter length of wire, thin wire. Wire cutters suggest ruler suggests how the student determines an accurate value of the diameter of the wire using only the apparatus listed. Draw a diagram, illustrate your method. Okay, so for the diameter, first thing is this, like you can have a scale and you can do this. Basically it's going to be no gaps would be over here. So one method is this. I'll explain it, just hold on. Okay, so you have two methods for this purpose by using these separators. So this is going to be method one. On the scale, you just tie up the wire in a loops, and then you divide, find out the distance of between A and B, and divide, then calculate the number of turns. So now you have to divide AB, and that is the distance between these 2 points with the number of turns to get the diameter of this wire. Or otherwise what you can do is, this is your method number two, and in this method you are going to do cut 6 centimeter long wires and then put them side by side, approximately 12 pieces, as shown in the figure. So this is basically scale, and these are 12 wires that are placed like this side by side. So basically there will be no space in between them, and on the scale mark the distance between A and B and find the distance. So again you have to divide that distance with the number of wires that are being placed between A and B, so which is 12, to get your answer. A second student determines the diameter using the different pieces of apparatus. His value of the diameter is more accurate. State the name of the different piece. So what you are going to use is micrometer, screw, gauge. Thank you very much.